Hey everyone, welcome back to another explainer. Today, we're diving into a date that honestly might just go down in tech history, Friday, June 26th, 2026. Now, if you were just skimming the mainstream headlines that day, you'd probably think it was just another standard Friday, right? But if you look closely at the underlying data, the raw benchmarks, and the massive infrastructure deals being quietly signed behind closed doors, wow. It was a day that literally rewired the future of artificial intelligence. We're going to cut right through all that marketing hype and shine a spotlight on the quiet giants who actually move the needle.
So, what actually happens when three massive, industry-altering milestones drop on the exact same day? Well, ironically, they kind of end up drowning each other out. The whole industry was looking the other way, totally distracted by flashy consumer apps and the usual tech stock roller coaster. Meanwhile, three absolute tectonic shifts in software capabilities, infrastructure, and hardware happened right under our noses. Today, we're going to extract the real signal from all that noise.
Actually, there's a quote that perfectly captures the whole vibe of this explainer. Tech writer Aaron Rose hit the nail on the head when he said, "The news cycle did not cooperate, the benchmarks do not care." And that is exactly it. The real advancements, the ones that are going to dictate who controls the next decade of compute and reasoning, they're happening off stage, totally eclipsed by consumer marketing wars. The scoreboards are being completely rewritten, whether people are watching or not. So, to make sense of all this, we'll be using what we call the Quiet Giants framework. Basically, looking at the foundational macro trends across software, infrastructure, and hardware.
Okay, let's dive in. Here is our roadmap for today. First, the signal through the noise. Second, Google rewrites the benchmarks. Third, SpaceX's billion-dollar compute empire. Fourth, OpenAI designs custom silicon. And finally, 5, the rest of the board.
Section 1. The signal through the noise.
Moving on to Section 2. Google rewrites the benchmarks.
All right, so leading into this historic Friday, Google quietly launched Gemini 2.5 Pro with a brand new feature called Deep Think. It's hands down their most capable model yet. But here's the crazy irony of the whole situation. They dropped the absolute best science model in the world, and developers barely even noticed. Just look at this gap on the GPQI Diamond benchmark. Now, if you know this test, you know it's notoriously brutal, a true test of graduate-level reasoning. Gemini hit 82.4%, which just completely blows past GPT 5.5's 76.3%. And they didn't stop there. It also smashed the record for MLLU Pro at 89.8% and bagged the highest score ever recorded on HumanEval Plus at 94.1%. Honestly, if you're doing any kind of heavy graduate research, complex math, or deep financial analysis, this was hands down the biggest development of the year.
So you might be wondering, how exactly are they pulling off these numbers? Well, Google's Deep Think is essentially an extended reasoning mode. Before it spits out an answer, it runs an internal chain of thought process. It thinks before it speaks. But of course, there's a major trade-off here. On one hand, you're getting a massive 15 to 25% accuracy boost on those really complex multi-step problems. On the other hand, it's going to take 3 to 5 times longer to actually get your response, and it costs about 4 times as much in token usage. We're talking around $10 for input and $60 for output per million tokens. So yeah, you're paying a hefty premium in time and compute to get that superior logic. Turns out graduate-level thinking isn't cheap, even for a machine.
And on top of that reasoning engine, they threw in a genuinely staggering number, a 2 million token context window. That is literally double what any competitor offers right now, and it comes with native video understanding. For developers and researchers, this means you can just dump entire code bases or hours of raw video into the model all at once. The thing is, Google has a distribution problem right now, not a capability problem. While consumer mindshare is entirely dominated by the competition, Google just delivered a serious capability advantage that nobody else can even touch right now.
Okay, Section 3. SpaceX's billion-dollar compute empire.
Now, software models are amazing, but they're really only as good as the physical infrastructure running them. So while Google was pushing the absolute limits of logic, Elon Musk's SpaceX was completely rewriting the playbook for physical data centers, specifically down at their Colossus facility in Memphis, Tennessee. Listen, if you take only one thing away from this explainer today about infrastructure, let it be this mind-blowing number, $80 billion. That is SpaceX's committed external compute revenue locked in through the year 2029. This absolutely shatters the mainstream narrative we've been fed. Colossus wasn't just some private sandbox built solely to train the Grok model. Oh no. It's been quietly transformed into one of the most lucrative commercial AI compute platforms on the planet. SpaceX is, for all intents and purposes, acting as a highly profitable commercial landlord for the entire AI industry.
Let's actually break down exactly who is footing that $80 billion bill.
Anthropic is the biggest tenant here. They've committed to roughly $45 billion. Then you have Google leasing capacity for about $30 billion. Cursor is in the mix too, though their exact amount is undisclosed. But honestly, the most strategically fascinating tenant is the newest kid on the block, Reflection AI, coming in with a $6.3 billion lease. If you haven't heard of them, Reflection is an American lab backed by NVIDIA and founded by some former DeepMind veterans. They are carving out a space as the ultimate sovereignty-safe option. We're talking frontier-level AI with open weights, which is absolutely perfect for governments and defense contractors who, for security reasons, just can't use closed US labs or Chinese open-weight models. And the best part for SpaceX, they get paid no matter who actually ends up winning the AI race.
Moving right along. Section 4. OpenAI designs custom silicon.
So, with software and infrastructure shifting so dramatically, the final piece of this giant puzzle is the hardware itself. Now, for years, OpenAI has basically been NVIDIA's biggest, most dependent customer. But by partnering up with Broadcom, OpenAI has taken its first real step out of NVIDIA's shadow. They unveiled a brand new chip, codenamed Jalapeno. But let's be clear about what this is and what it isn't. Jalapeno is an ASIC, an application-specific integrated circuit. That means it's custom-built for one very specific job, inference. It is not designed to train models. It is designed to serve those models to users at massive scale. See, NVIDIA's GPUs are super flexible, which is amazing for training, but they are incredibly expensive to run. For a company like OpenAI, serving models, the inference side, is where the real long-term money is. Every single dollar they spend on NVIDIA hardware is a dollar lost from their bottom line. So Jalapeno is a direct attack on those unit economics. They're optimizing specifically to make running their models vastly cheaper.
And that brings us to what is honestly the most mind-bending detail of the entire week. Check out this timeline. Jalapeno went from its initial design phase all the way to manufacturing tape-out in just 9 months. Now, how is that even possible? Through AI-assisted acceleration, OpenAI literally used its own advanced AI models to speed up the design of the physical chip that will eventually run its AI models. It's this massive, crazy, recursive loop. AI accelerating AI infrastructure. Even OpenAI's president admitted they were surprised by just how much their models sped up the physical engineering process. It's truly wild to see this happening in real time.
And they definitely aren't starting small either. The plan here is gigawatt-scale deployment by the end of 2026, with Microsoft stepping in as the primary partner and guaranteeing 40% of that very first production run. Just to put that into perspective for a second, a gigawatt-scale data center means you are drawing the electrical power of an entire modern city just to serve AI inference. That is the kind of mind-boggling scale they need to efficiently run their upcoming models like GPT 5.6 Sol. We are watching OpenAI transform right in front of us, going from a software lab to a full-stack compute titan.
Finally, Section 5, the rest of the board.
The sheer velocity of the water ecosystem on this exact same Friday was just off the charts. Let's do a quick rapid-fire rundown of the other big shifts. Over at Anthropic, their Fable 5 and Mythos 5 models remained offline for a 14th consecutive day. Meanwhile, OpenAI just kept pushing forward, announcing a limited preview of their new model trio, GPT 5.6 Sol, Terra, and Luna, while officially retiring GPT 4.5. And because of the downtime elsewhere, we saw models like GLM 5.2 and Minimax M2.5 aggressively stepping in and absorbing all that displaced enterprise developer traffic. Oh, and totally in the background, there's a massive $20 billion merger for Cohere just sitting there waiting for regulatory approval. The whole board is realigning at breakneck speed.
Which brings us to our final thought for today's explainer. We are now looking at a world where AI models are literally smart enough to design the very hardware they run on. Raw computational power is quickly becoming the foundational currency of this entire new economy. So, if the companies that control the inference pipelines also control their own destiny, as these quiet giants vertically integrate everything from the silicon all the way up to the software, who truly controls the physics of the future? Definitely something to chew on as you read the headlines this week. Thanks so much for joining me for this explainer, and as always, keep learning.